Welcome to the Deep Dive. Today, we are taking you into, well, a world most people don't see. Aircraft maintenance.
That's right. The MRO world: maintenance, repair, and overhaul.
Exactly. And when you step onto a plane, you're putting your trust not just in the pilots, but heavily on these ground crews.
Absolutely. They work behind the scenes, often in some pretty demanding environments.
Yeah, demanding is maybe an understatement. Our sources today talk about environments that are, well, far more dangerous than you might think.
We're talking about working inside the aircraft structure itself.
Particularly in confined spaces, right? Like fuel tanks, wing voids, places like that.
Precisely. And that's where the real hazards lie.
Our sources paint this picture of a constant battle. There's the physical safety risk, obviously. Then there's the pressure of, tight schedules, avoiding delays.
Always a factor in aviation.
And on top of that, the compliance challenges, dealing with volatile jet fuel vapors, maybe even oxygen-deficient air. It's a triple threat.
It really is a hazardous intersection. We're not talking about changing the oil in your car here.
No.
We're talking about entering spaces that could potentially be explosive. Jet fuel, especially something like Jet A, leaves these persistent vapors. They're toxic and flammable.
So before anyone can even go in to do an inspection or a repair.
Right. They have to purge that space completely, get the atmosphere below what's called the LEL, the lower explosive limit.
And make sure there's enough breathable air, obviously.
Critically important.
And the shape of these spaces, the wings, that makes it way harder, doesn't it? It's not like venting a simple boxy room.
Oh, absolutely. You've got the internal structure of the wing, baffles, little pockets, places where vapors can just sit.
Stagnate.
Exactly. Stagnation is the enemy. Even after you drain the fuel, those residual vapors can build up fast.
And using the wrong kind of fan or not enough airflow.
That's led to serious incidents in the past. Ignitions, people collapsing from lack of oxygen. It makes ventilation equipment absolutely critical, life support level critical.
Okay, so let's unpack the solution then. Our mission today is to really understand the engineering answer to this. We're diving into the tech specs for certified ventilation gear, stuff designed specifically for this globally. We're using systems like those from RAMFAN as a kind of case study.
Good example, yeah.
We need to get our heads around how this purpose-built tech gives better protection, lets crews work faster, and ensures, total compliance with aviation standards.
Well, the key is specialized, purpose-built tools. That's the big takeaway. Standard industrial fans, they just don't cut it.
Right. Not explosion-proof enough, not the right airflow.
Both, really. The industry realized you need specific designs. Our sources talk about two main types of solutions.
Okay.
First, there's what you might call an aircraft fuel tank ventilation kit. This is for really focused work, getting ducts right inside the tank or the fuel cell.
So attacking the vapors right at the source. Precision work.
Exactly. Then there's the second type. More mobile, ready-to-go solutions, like the wing tank vent cart.
Okay, what's the role of that one?
Think of it as a portable air quality station for the ground crew. Rugged, easy to deploy quickly, often used for pre-flight checks or quick servicing jobs. Provides high-volume airflow for the wider work area.
Gotcha. So one for deep inside, one for broader, faster deployment.
Sort of, yeah. But both shared that non-negotiable goal: continuous explosion-proof airflow.
That seems to be the magic phrase. Explosion-proof.
It is. Protect the technicians, stop vapor buildup, keep the environment compliant, but getting both explosion-proof and high performance, that's the real engineering challenge.
Right. This is where it gets interesting, moving beyond just fans to, deep engineering standards.
Exactly. The absolute must-have is that explosion-proof design. Every single component, motor, housing, wiring, switches, everything has to be designed so it can never be an ignition source.
Even if it's operating smack dab in the middle of a fuel vapor cloud.
Precisely.
But what does explosion-proof actually mean in this aerospace context? Is it just about sealing things up tight?
It's way more than just sealing. These systems need formal certification for hazardous location use.
Okay.
Internationally, this usually means certification for specific zones. An aircraft wing tank. That's typically a Zone 1 or Zone 2 explosive atmosphere risk, very high risk.
Which dictates?
Everything. The materials used: non-sparking metals, specific plastics. The motor design has to contain any potential internal spark, stopping it from ever reaching the outside atmosphere.
Wow.
And there's another thing: static electricity. High-velocity air moving through ducts, especially plastic ones, can build up a static charge.
Oh, I hadn't thought of that. Like rubbing a balloon on your head?
Kind of, yeah, but potentially catastrophic in this environment. So these certified systems have built-in grounding and anti-static features throughout the hoses, the fan body. Everything's designed to dissipate any charge safely and instantly.
That detail, the static buildup, that really shows the difference between some generic blower and a system truly designed for this hazard. You're fighting chemical risk, physical risk, and electrical risk all at once.
You absolutely are.
Okay, now let's talk globalization. MRO is global. A plane gets serviced in London, flies to Sao Paulo, needs another check. The gear needs to be legal and safe in both places.
And that's a huge hurdle. The equipment has to be certified pretty much worldwide.
It's not enough just to meet, say, U.S. standards or European standards.
Not at all. Our sources highlight that the leading systems really need a trifecta of global certifications. They list ISEX, in-metro, and CE hazardous location markings.
Okay, let's break those down for the listener.
Yeah.
CE, ISEX, in-metro. Sounds like alphabet soup, but I gather they're major deals.
Huge deals. Monumental engineering and auditing hurdles, like you said. CE marking is pretty standard for products sold in the European Economic Area. It shows basic conformity.
But the key ones for explosive atmospheres are the other two.
Right. ICX is the big one globally. It stands for the International Electrotechnical Commission System for Certification. Basically, for equipment used in explosive atmospheres.
The gold standard.
Pretty much. It aims for global harmonization. If something is IESEX certified, it means it's been rigorously tested to strict international standards, making it acceptable in many, many countries.
Okay, and in metro, why is that specifically mentioned?
In metro is the certification needed for Brazil. Brazil's a major aviation market, but they have their own specific, quite demanding requirements. Often needs separate factory audits, additional tests, beyond even the IESEX process.
So getting ISEX and in metro plus CE, that's serious business.
It really demonstrates a manufacturer's commitment and capability. It shows they can handle complex, differing global regulations. Building a specialized tool is one thing. Building one that's universally approved is another level entirely.
That really frames the challenge. It's building a safe fan, sure, but also navigating this global web of rules so MRO work isn't held up by compliance issues.
Exactly. Seamless global operations depend on it.
Okay, beyond the certifications, these things need to actually work day in, day out. In hangars, maybe out on the tarmac sometimes. They need to be tough.
Absolutely. Physical durability is crucial for reliability. Our sources mention a specific rating. Ingress protection, IP55.
IP55. What does that mean for you, the listener?
Well, the IP stands for ingress protection. The first 5 means it's protected against dust getting inside. Really important in a hangar environment, which isn't always pristine.
Makes sense.
Yeah.
And the second 5?
That means it's protected against water jets from any direction. So if there's a sudden rain shower on the tarmac or someone's hosing down the area nearby...
The motor and electrics stay safe and sealed.
Exactly. That ruggedness directly impacts reliability and, therefore, the maintenance schedule.
And schedule, as you said, is everything in aviation.
Which brings us to performance. High airflow isn't just nice to have, it's about speed, right? Getting the job done faster.
It's critical for speed and safety. These systems need strong, consistent airflow to clear those vapors rapidly, meeting those tight turnaround times.
What kind of performance are we actually talking about? We're talking about achieving multiple air changes per hour inside that confined space. These aren't just moving air around. They're designed to actively pull contaminated air out and push fresh, clean air in.
The goal being to get that LEL down fast.
Get it down and keep it down. Safely, compliantly, and in the shortest possible time. If you can cut the ventilation time needed before entry from, say, 3 hours down to 1.
That's a massive gain for the MRO facility. Saves time, saves money.
Huge gain, all while actually improving the safety margin.
And aircraft aren't all the same shape and size. You've got everything from small regional jets to huge wide bodies.
Yeah.
The ventilation system needs to adapt.
Oh, definitely. Adaptability is crucial for the workflow. Good systems have modular designs, flexible anti-static hoses.
So technicians can rig it up properly for whatever specific aircraft they're working on, match the geometry, access ports.
Exactly. You need to get the air where it's needed, regardless of the plane's internal structure. That operational flexibility is key. Make sure the gear you buy today works for tomorrow's fleet, too.
Okay, let's connect the dots. We've got explosion-proof design, these tough global certifications like ISEX and in Metro, the IP55 rating for durability. How does all this tech actually save the day in the MRO world? Where does it make the biggest difference?
Well, it hits several critical points. First and foremost, fuel system operations. Cleaning, inspection, repairs inside tanks. These systems provide that guaranteed safe, controlled ventilation, minimizes exposure, ensures the environment is signed off as safe.
Right, the core job.
Second, confined space entry. We touched on this. It's heavily regulated everywhere. These systems ensure that steady flow of clean, breathable air. They actively prevent oxygen deficiency, which is a silent killer.
I bet it helps with the paperwork, too. Having certified gear must make compliance audits smoother.
It absolutely does. Using certified tools shows you're proactively meeting safety and environmental regs. You're controlling hazardous vapor release, protecting workers, protecting the environment. That's vital for any MRO facility to keep operating legally.
Essential stuff. And finally, hitting those deadlines.
Yep. Pre-flight operations. Sometimes you need to quickly purge an area before the aircraft can go back into service. Having reliable, fast ventilation directly supports shorter maintenance cycles, less downtime.
And this applies across the board. Big airlines, military, smaller planes.
Yes, the principles are the same, whether it's a commercial hub, a military air base, or a general aviation shop. Downtime costs money and impacts readiness. Safe, rapid ventilation is the solution.
So let's sum this up for you, the listener. What does it all mean? Our deep dive today really confirms that this kind of specialized ventilation isn't just optional, it's non-negotiable for aerospace safety.
Absolutely non-negotiable.
It's this blend of really specific, explosion-proof engineering,
Mm-hmm.
verified by tough global standards like ISEX in Metro, CE,
Mm-hmm.
mixed with practical things like durability, that IP55 rating, and just raw performance to get the job done quickly.
It shows that when lives and incredibly expensive assets are involved, the safety gear has to be purpose-built to the absolute highest standard.
Especially if you want both speed and compliance in these really high-risk environments.
It's a fascinating glimpse into the unseen technical side that keeps planes flying safely.
It really is. And, thinking about how necessary these complex certified tools are, it raises a final question for you to mull over. Given that maintenance crews need these kinds of ventilation solutions just to access and safely work inside wing tanks, how much does that need, the need for maintenance, safety, and access, actually influence the basic design of aircraft fuel systems right from the start?
Ah, that's interesting. Is the need to ventilate shaping the structure itself?
Yeah. Are engineers designing fuel tanks differently now, knowing they have to be efficiently and safely purged later? That's a structural and design question maybe worth pondering on your own.